All right, so the X's are the domain and the Y's are the range. And it's very simple to tell in a set of ordered pairs. What the domain is. What's the domain there? 1 through 5. What's the range? 2, 4, 6. It's also easy to tell in a mapping. These are the domain, those are the range. Similar, very, very similar would be a table. And I know I'm using really simple numbers, but the X's are the domain and the Y's are the range. It's not as simple when you have a graph. Not as simple when you have a graph to look at domain and range. But this is the kind of stuff that we've been doing forever, right? Y'all been finding domain and range for a good long time. So what if all of a sudden I had all these different kinds of graphs that we're going to be graphing, and I was simply asked to find the domain and the range for each of them. This is, I'm sorry, not in your packet. So if you want to do sketches somewhere, that's probably a good idea, because this is probably the hard part. Now this is a square root function. And while we're talking about domain and range, I should also mention, just make several little bitty graphs on graph paper, on regular paper, just do sketches. They don't have to be perfect, okay? You can write the equation with them if you want to. But in order to determine if a graph is a function, do you remember using the vertical line test? Okay. How do we use the vertical line test? If I have a graph and I'm going to determine if it is a function. And let me have your attention real quick here, and then I'll let you copy. If I draw a vertical line on that graph, anywhere on that graph, and it touches more than one point, then it's not a function. Okay, so there's all my vertical lines. I drew them. So is this a function?
Yep.
It sure is. And I gave it away because I said it's the square root function. The way I know it's a function is because if I draw any vertical line and I can hit more than one point, it's not a function. See, the square root function has a beginning point. It's kind of like a ray, but it's a curve. It goes infinitely in one direction, but it is a function. This is a cube root, and it's got a little hitch right there in the graph, a little critical point right there. Actually, it's a function. That graph doesn't look like it, but actually, it just does. It comes down and it's just a little curve like that. And no, it looks like it's doing a whole lot right in there, but no, it's actually a function. Is a vertical line a function? It is not. It is the only linear equation, linear graph that is not a function. The only line that would not pass the vertical line test is the vertical line itself. Vertical lines are the rebels of the lines. They are not functions. They have no slopes. They can't be written in slope-intercept form, so they go against all the rules they can, okay? They're the rebels. This is an exponential. We just did a little test today on exponents, right? If I graphed 1/2 to the x power and then multiply that by 5, I would get this little curve right here. Now what happens to the left-hand side of the curve is it goes to positive infinity, but it never gets vertical. As it goes up, it goes out. And then it comes down here and it approaches, I'm using mathematical terminology, listen carefully. It approaches the x-axis but cannot touch it. All right, somebody tell me why. Why can this curve not touch? Look at this equation right here. Why can this curve not touch the x-axis?
It's the x power. Because y equals it.
Y equals all of them. Okay, let me get you there. Keep listening, okay? For a point to be on the x-axis. With me so far? For a point to be on the x-axis, what does y have to be?
0.
0. What can I plug in for this x to make y 0?
0.
What's anything with 0 power? What if I do a negative exponent? What happens? I just flip it. Did it make it 0? No, it's actually going to make it bigger. Instead of 1/2, it's going to be 2. What could I plug in for x to make y 0? Nothing. And so we're talking heavy duty graphs, okay? There is nothing I can make x to make y 0, and so this curve behaves in such a way that it approaches y being 0 on the x-axis, but it never gets there. A line that a curve approaches but does not touch is an asymptote. It's like an electric fence. You put a small lamb or a little calf inside an electric fence, and after the first time that little cold, wet nose hits that electric fence, what doesn't happen again? They don't touch it again. The asymptote's like that too. It keeps this curve in the pasture. Okay, it keeps this curve from going negative. Also, I should say that not only can y not be 0 here, it also can't be negative, right? There is nothing that I could plug in for this x, take 1/2 to that power, multiply it by 5, and make y negative. So this curve cannot come down here and cross, become 0, or become negative. That's why, and I have to be careful when I say this, the x-axis is an asymptote. Okay? The circle. Is it a function? No. If it's not a function, what is it?
Not a function.
Right. What do you call them? If they're just a set of ordered pairs that doesn't meet the requirements of being a function. A relation. It's just a relation. But this is the equation of a circle. It has a center at -1 right down here. It has a radius of 3, go out 3 all the way around. But it's not a function. Did y'all get all those copied down? A sketch made? Alright, now let me go back and talk about domain and range. Alright, now when you read a graph, you read it like you read a book. For the domain, you read from left to right. Alright, so if I'm talking about what can the x's be, where's this curve going to go on the x-axis?
1 to infinity.
Does it start at 1?
0.
Starts at 0. That's right. How do I write that? The domain would be the set of all x's where x is greater than or equal to 0. That's the only way I can express an infinite domain. But it does have restrictions because it can't be less than 0. It starts at 0, 0, the origin. Now I read a range from bottom to top. From bottom to top, on the y-axis, what can y be? It starts at, what's y? Right here.
0.
0. And where does it go? Well, as this, I always call this the broken arm graph. You know, somebody that's interactions, what it kind of looks like. As it goes out, it also goes up slightly. It doesn't ever get horizontal, okay? As it goes out, it goes up slightly. But it does go up. So what do you think the y's would be? Same thing. Is there number that I cannot plug in for x here and take the cube root of it?
Zero.
Hey, zero's a wonderful number. I can take it to any power.
So no.
I can take it to any root, and it's just like 1. Its answer is always 0. Is there any number that I cannot plug in for x and take the cube root of it? I mean, think about your calculator. Picked up your calculator, you started plugging in numbers. You did negatives, you did positives, you did fractions, you did decimals. Was there any number you couldn't take the cube root of?
No.
There isn't. So what's its domain? Where does this curve go on the x that way and on the x that way? Goes everywhere, doesn't it?
Yeah.
So its domain is all real numbers. Now see, as long as we're in our book and we're looking at tables and sets and mappings and we're finding domain and range, that's easy. Mm-mm. Is there any way to make y 0?
Zero.
How can I make y 0? What's x going to be?
You put a negative number where that X is.
You're going to put a negative number where that x is. What's that negative number?
1.
The cube root of negative, you don't keep thinking. The cube root of negative 1 is negative 1.
Yeah.
What do I need this to be to add to 4 to give me 0?
Negative 4.
Alright, so the cube root of,
Oh, that's bad.
what? Negative 64. Negative 64 would give me a 0. Alright, think about graphing that thing. You're talking about on the x-axis being at negative 64 before it hits 0. But it's going to hit it, isn't it? I mean, eventually. We'll be all taping graph paper together across the room, but we could graph that, okay? Then, could it be negative? What is the cube root of negative 729?
9.
Negative 9. What's negative 9 plus 4?
5.
Negative
Negative
5. So could y be negative eventually?
Eventually.
Okay. So what's the range?
Infinite.
All real
All real numbers, yeah. So the domain saying what can x be, or what can it not be, and the range is saying what can y be, or what can it not be. All right, vertical line. What's the domain?
All real numbers. No function.
It's not a function, you're right. It's a relation. But what's its domain? What?
2.
X is always 2.
Okay.
What's its range? Where can it go on the y? Up and
All real
down.
numbers.
Yeah, everywhere, all real numbers. Are you starting to see how to find domain and range with a graph? It takes a lot of practice. It takes a lot of
We're
practice.
gonna have to keep practicing.
Yeah, we're gonna keep going here. All right, let's look at this exponential curve. This looks like a whole lot like another one. No, this is one we talked about, wasn't it? This is one we talked about. What power can I plug in for x? Negatives? Fractions?
There's
0?
There's not one.
Positives? There's not one I can plug in, or I can plug in all of them?
All of
I can plug in all of them. I can plug in all the x's. Keep trying. You're doing good compared to all these people that are sitting there and writing down what I write down. Yeah, I think, okay? Now, what can y be?
Nothing. Wait,
them.
what?
All real numbers.
Like, it can go positive. It can come down here and reach this asymptote
All positive numbers.
and get infinitely close to zero, but is it going to get there?
No.
Okay.
All positive numbers.
So how you write that?
There's probably some word for it.
Y is less than or equal to 1.
Give me listen.
No,
Greater than
greater than
Y
go.
greater than
1.
0. Yeah, greater than 0. Right?
Well, can I just say greater than zero, but not or equal to zero? Because you could do very, very, very close to zero. You know, you just can't get to zero. Remember the electric fence. Think about an asymptote this way. If I said, now I want y'all to think, don't like go into your biggest thinking area. Put on the biggest thinking cap you got, okay? And don't be literal. Let's think about this way. If I said I'm going to go halfway to the door, and I'm going to keep doing that. I'm going to go halfway to the door. And I keep doing that. I'm going halfway to the door. Am I ever going to get to the door?
No.
Physically, yes, but theoretically, am I ever going to get there? Half of what is zero distance where I'm at the door? Half of what? I'd have to start at zero to begin with, wouldn't I? So unless I started out at the door, am I going to get to the door? No, not theoretically. That's an asymptote. It's approaching it, and here's what you say. This is getting way ahead of the game, but we would say on this curve right here, as x approaches zero, doesn't get there. What does my curve do?
Gets curvier.
It doesn't get curvier, it almost flat lines out. Because it's going to approach that x-axis.
Decreases.
What?
It goes down.
Okay, good. As it goes down, and y goes 1/2, 1/4, 1/8, 1/16, 1/32, 1/64. What's it approaching if it gets smaller?
Zero.
Zero. Is it going to get there? No. All right, we good? Everybody stressed out? Everybody's rubbing their head? Everybody's crying? Good. Okay. That's it, Logan. All right, so let's look at this circle. All right. What's this domain? Read a graph like you read a book from left to right when you're looking at the domain. Where does it start? Where does it stop? It goes between -4 and 2. What about the range? It goes from bottom up.
-4 to 2.
Let's say this is 1, 2, 3, 4. Yeah, -4 to 2. Yes, ma'am.
The only one of those that I understood was the vertical line and the circle.
Oh, don't tell me that. When you think about domain, you're thinking, what can X be? And then you kind of think negatively about it. You kind of think, well, what could it not be? Is there anything it couldn't be? Because anything it can't be is not in the domain. Anything Y can't be, when I look at my equation, when I look at my graph, that's what, what goes in the range of what's left, what it can be. I think we just got to practice a lot, and we're going to. All right. Would y'all jot these down? I want you to see if you can give me the domain and the range of each sketch you make, okay? Oh, and by the way, tell us their functions or not.
What was that rule again?
The vertical line test, if you use the vertical line and it hits more than 1 point, it is not a function.
So if it's 1 point, it is.
Yes. Sketch the graphs. Then beside each of them, say yes or no if it's a function, and give the domain and the range.